Okay, now after data transfer instruction we have seen arithmetic instructions. Okay, and in the yesterday's class we have seen the logical instructions. Okay, so see here we have already covered the 5 addressing modes. Then the first set, that is the data transfer instructions supported by 8051. Then arithmetic instructions supported by 8051. Then the logical instructions supported by 8051. Okay, now today we are going to see the boolean or bit manipulation instructions. Now see what is mean by boolean or bit manipulation instruction. Now see 8085. See, in MMC we are going to deal with two parts simultaneously, microprocessor and microcontroller. Now if we consider about the microprocessor, what we can say, microprocessor is always byte accessible. What is mean by byte? It is a combination of 8 bit. Okay, so whenever you want to give the data as an input, whenever you want to receive the data as output, or whenever you want the processing of the data, it is always done with the help of byte. Okay, now what is mean by byte addressable or byte accessible? So see, whenever you want to give the data, you have to specify the 8 digits, 8 bits. Then and then only microprocessor is going to operate on data. That is called as a byte addressable. Okay, now microcontroller. What about the microcontroller? In the microcontroller, some of the instructions are bit addressable, some of the instructions are byte addressable. Now what is mean by bit and byte addressable? So see, first thing, what is mean by byte addressable? Byte addressable means you have to give one byte. One byte is nothing but combination of 8 bit. Means what? Every time you have to give the data at least 8 bit data. Okay, now after giving the 8 bit data only it will cooperate. It will operate on that data. For example, as we know that what are the registers we are having, that is A register, B register, R0 to R7. All these registers are 8 bit. Means what? Maximum they can store 8 bit data. Okay, now in the microprocessor it is also bit accessible. Means what? No need to give every time 8 bits. If you are giving 8 bit to it, it is okay. Okay, so it is okay with the microcontroller that it will receive the 8 bit data. But some of the instructions are like that, if you are given the single bit, okay, then also it can operate. जर तुम्ही एकच बीट दिलं, मायक्रोप्रोसेसरचं काय होतं की तुम्हाला एकाच वेळेस 8 बीटला द्यावं लागत होतं. तुम्हाला अक्युमुलेटरला व्हॅल्यू द्यायची, यू हॅव टू नीड टू स्पेसिफाय द 8 बीट व्हॅल्यू. ओके, म्हणजे काय, प्रत्येक वेळेस डेटा देताना तुम्हाला 8 बीट मेन्शन करावेच लागत होते. त्याला काय म्हणायचं, बाईट ऍड्रेसेबल. ओके, सो जेव्हा तुम्ही 8 बीट डेटा देताल तेव्हाच तो त्या डेटावर ऑपरेट करणार. 8 बीटच डेटा इनपुट म्हणून घेणार, 8 बीट वरच ऑपरेट करणार आणि 8 बीटच तुम्हाला आउटपुट मध्ये देणार. नाव 8च बीट देईल का, एका वेळेला तो 8च बीट देईल. ओके, सेकंड मध्ये तो तुम्हाला नेक्स्ट पुढच्या 8 बीट देईल, नेक्स्ट परत टाइम स्लॉट मध्ये पुढच्या 8 बीट देईल. असा तो इन्फायनाइट डेटा कव्हर करेल. पण एका वेळेला किती देणार, 8 बीट देणार. कोण देणार, मायक्रोप्रोसेसर. and that's why microprocessor is called as a byte addressable. मग मायक्रोकंट्रोलरचं काय आहे, तर मायक्रोकंट्रोलर हा बीट ऍज वेल ऍज बाईट ऍड्रेसेबल आहे. म्हणजे काय की सम ऑफ द इन्स्ट्रक्शन्सला some of the instruction needs 8 bit data, that is data in 1 byte or the byte format. But some of the instructions are like that, they can operate on a single bit. Okay, that's why it is called as a bit addressable as well as byte addressable. Okay, now whenever we have seen the memory organization in the microcontroller, there is a specific area reserved for bit manipulation. Okay, means what? So whenever such a bit manipulation instructions we are going to deal with, at that time bit manipulation instruction use that space to save the data temporarily or to receive the data from that area. Okay, so reading and writing of the single bit data is possible by using the bit addressable area. Okay, now here you have to just remember two things. What? Microprocessor is byte addressable, microcontroller is bit as well as byte addressable. Now first thing, Second thing, what is mean by byte addressable? In the byte addressable, we have to compulsory specify minimum 8-bit data. Okay. Now, what is mean by bit addressable? Bit addressable means it will work on single bit. Okay. एक जरी bit त्याला मिळालं तरी तो त्याच्यावर काम करतो. Now, bit addressable and byte addressable. Who is going to decide that one? Instruction sets. Okay. Some of the instruction require compulsory 8-bit data. Some of the instruction requires single bit as well. Okay. So some of the instructions support the single bit, that is called as a bit addressable. Some of the instructions supports byte addressable data, means at least you need to give the 8-bit data to the microprocessor. Is it clear? Is it clear? Hello? Yes or no? Bit addressable means you need to specify 8-bit data. Byte addressable means you need to specify 8-bit data. Bit addressable means it works on only on the single bit. Okay. Now see, there are the some of the instruction. Now see, all the names suggest Boolean or bit manipulation instructions will deal with the bit variables. We know that there is a special bit address area in the RAM, and some of the special function register, that is SFRs, are also a bit addressable. Okay, the mnemonics corresponding to the bit, Boolean or bit manipulation instructions. Now see, which are these kind of instructions? See, clear. So CLR C, what is means? It will only clear the carry bit. Okay, means after execution of this instruction, only carry bit is going to be set or reset. In the clear, it will reset. In the set, it will make as a 1. म्हणजे इथं बघा, तुम्हाला 8 बीट मेन्शन करायची गरज आहे का, किंवा तुम्ही 8 बीट वर काम करताय का? नाही, आपण फक्त सिंगल बीट 1 किंवा 0 करतोय. एकच बीट आहे ना कॅरीचं. सी मीन्स सिंगल बीट, दॅट्स व्हाय इट इज कॉल्ड एज अ बीट मॅनिप्युलेशन. कळालं का? हॅलो हॅलो. So see here, CLRC means what? Clear carry, means you have to make carry bit 0. Okay. Next, CLRB bit means you can use any bit here. Like if I have written that CLR, if I have written like that, for example, CLR bit, instead of bit, if I write PSW.4, what it means? Whatever the 5th bit of PSW, it will clear. That is PSW.4 bit is going to be 0. Okay, so here bit is specified. You can specify any bit. Is it okay? Is it okay? For example, clear P0.1. What it means? See, port 0 चा second bit. Okay. See, if I have written P0.0, what it means? Port 0 चा first bit. If I have written clear P2.1 or 2.3, what it means? You have to make, clear means you have to make it 0. Which bit? P2.3. What it means? Port 2 having total 8 pins. Okay, but out of the 8 pin, you are just making the third, that is 4th number pin. It always starts from 0. So 3 here means it is a 4th pin. You are making it to 0. Is it okay now? Okay, you tell me. If I told you that write the instruction for making port 3 second bit 0. How you can write? Port 3 चा second bit 0 set करा. तर तुम्ही instruction काय लिहिणार? 0. You have to make 0 means you have to set or you have to clear. If you want to make to 0, then whether you have to making that bit as a set or whether you have to make that bit as a clear.
Clear.
If you want to make that bit 0, then you have to use the word clear or set.
Clear.
Clear, very good. Now which bit you have to make to 0? second bit of port 3. Okay, so see here how you can write it's clear. Clear why? Because we want to make that bit 0. Which bit? Port 3, 1. So P3.1 means this instruction is going to make second bit of port 3 which is equal to 0. If I told you that make seventh bit of port 2 to 0, how you can write? Seventh bit of port 2, you have to make that pin or that bit 0. How you can write? Likewise same. काय करायचं तुम्हाला? पोर्ट 2 चं 7th बीट 0 ला सेट करा. असा जर क्वेश्चन असेल तर तुम्ही काय करायला हवे? कोणती इन्स्ट्रक्शन लिहिणार?
Layer.
Yes.
Layer P 2.7.
Very good. It's clear P 2.7. What is mean by that? What is mean by that? Clear means you have to make that pin equal to 0. Which pin? 7th pin. Okay, kunachi of port 2. That's why P 2.7. Now see here, whenever we want to clear the 7th pin, need not to give 8-bit data. Okay, see, there is another way to make the 7th bit of the port 0 as a 0. How? See here. Port 0 contains total how many pins? 8 pins. Okay, these are the 8 pins. That is 1, 2, 3, 4, 5 and 6, 7. So you have to make the, see here, here is a 1, here is a 1, 0, here is a 1, here is a 2, here is a 3, 4, 5, 6 and 7. Okay, so see, we want to make this pin as a 0. So how I can write? Move P2 comma A, and I have to assign before that move A comma 0 0 means what? H means what? 0 0 value I have assigned to A, and I have to write that, I have to transfer that 0 0 value into the P2. In this way also I can make 7th pin as a 0, but while assigning the 7th pin 0, I have to specify all the remaining 7th bit. Means what? In short, I need to give the data of 8 bit. So this type of method is called as a byte addressable. How we can call it as a byte addressable? Why it is a byte addressable? Because we want to make this pin 0. So for making this pin 0, we have to specify all other bits also. Okay. So no need to give, means आपल्याला काही सांगितलं नाहीये काय की हे सगळे बिट्स तुम्ही 1 करा, म्हणून आपण बाय डिफॉल्ट काय करणार? त्यांना इनएक्टिव्ह ठेवणार. आपल्याला कशात इंटरेस्ट आहे? ओनली वी आर इंटरेस्टेड इन 7th पिन. Okay, so we are making intentionally this bit as a 0. Okay, so see here, so whenever I want to make the 7th pin 0, I need to specify the 8-bit data, that is called as a byte addressable. Okay, this is one way. In the another way, in a bit addressable, how I can write in the bit addressable? Same operation. Which operation? Making the 7th pin 0. That is, I can write clear P 2.7. Means what? I have only cleared the single bit. Here I am only dealing with the 7th bit. I need not to care about all these other bits. Okay, I have not specified anything about these bits. I have only specified about the 7th bit, and that's why it is called as a bit addressable. Understood? So some of the instructions are byte addressable, where you have to mention the byte means data, 8-bit data. So some of the instructions are bit addressable, where you have to specifically you have to mention that bit only. Okay, here we are interested in the 7th pin of the port 7, so I have written only 7th pin. Okay, so but in this case, in such type of the byte addressable area, we have to intentionally make other bit 0, and then we have to write the equivalent value. For this 4, here is a 0, for this 4 0, here is a 0. So I have to write move A comma 0 0. So that 0 0 value is assigned to the port 2 and automatically it will make the bit P as a 7th bit as a 0. So this is a byte addressable and this is a bit addressable. Understood? Hello? Have you got the concept or
Yes,
not?
ma'am.
Everyone? Yes? So some of the instructions are bit addressable. So see, which are such type of instruction? Compulsory such questions is going to ask in the university exam. Explain any two types of bit addressable instructions. Whether move is a bit addressable? No. Whether again add, subtract, whether it is a bit addressable? No. Why? Because while performing these instructions you need to specify 8-bit data. Okay, so that's why these all instructions are byte addressable. Then which are the bit addressable instruction? First instruction is clear. Means what? Clear. C. Clear च्या पुढे तुम्ही जे काही लिहिताल ते बीट फक्त 0 ला सेट होणार आहे किंवा त्याची व्हॅल्यू फक्त 0 होणार आहे. ओके, so clear C means you have to make carry bit only equal to 0. Clear bit, you can specify any bit over here like PSW 2.3, PSW 1.0 or any other register. IE.1 that is instruction register second bit, IE.0 instruction register 0th bit. Like again we are having number of SFRs like for example P1.2 that is third bit of port 1, P0.3 that is fourth bit of 0th port. Okay, so instead of bit you can mention any bit here. So clear is a one type of bit addressable instructions which work on single bit. It will make that bit equal to 0. Okay, so size of this is a 1 byte and if you specify the another number, any register value over here, then it is contains 2 bytes. What is the use of this byte? So after execution of the instruction, your PC is incremented by this number according to the size of byte. Okay, next see set, SET. Set means you have to make that any bit 1. So see set carry. What it means by set carry? You have to make carry bit as a 1. Okay, next set bit. So see here again we will see the example with same. What if you want to make 7th bit of port 2 1, then you have to write here set P 2.7. Okay, so what it means? You have to set means you have to make that bit is equal to 1. Which bit? Port 2.7 means port 2 चा 8th bit जे आहे ते तुम्ही काय केलं 1 केलं. So this is called as a bit addressable. Why? Because while setting the bit you are only dealing with that bit only. Okay, now same can be implemented by byte addressable. Now how you can implement? See here. Now as what we know that port 2 has a 8-bit pin. So here is a 0, 1, 2, 3, okay, 4, 5, 6 and 7. What we want to make? We want to make 2 points, that is 8th bit. 7th bit is equal to 1. So you have to make remaining all the bits to 0. So what is the hexa equivalent? Now you tell me what is the hexa equivalent of this? Instead of this, how I can write? What I can write here? Past. 1000 means what? It's 8. So it's 8 and it's 0. So how I can write? Move A comma hash 80H. And then I can write move P2 comma 80, sorry, A. Means what? In short, this 80 value is going to transfer into the P2. Okay, so this type of addressing is called as a byte addressable. Why? Because you are interested in only one thing. Which thing? Making the 7th bit, 8th bit to 1 equal to 1. But for that you have to specify the value of all other bits. Okay, So this is called as a byte addressable. By using these two instructions, same operation is done as like of set P2.7 is equal to 1. Okay, so why these bit addressable instructions are introduced? Because while dealing with always with the byte addressable, it is quite complicated. Why complicated? Now see, here we are interested only this bit to making 1, but for this one you have to make all these bits equal to 0. Unnecessary, you have to deal with other bits also. Okay, so to avoid such type of complication, there is a bit addressable instructions are there. So set is a bit addressable instruction which makes this particular bit is equal to 1. Okay, so this is bit addressable and this is byte addressable. So now everyone gets clear idea what is byte addressable. What is byte addressable? You have to specify 8-bit data. Okay, what is bit addressable? You have to specify only single bit. Okay, so repeat with me. जर आपण 8 बीटचा डेटा देत असू तर तो कोणता ऍड्रेसेबल झाला? बीट का बाईट? सांगा. व्हेरी गुड. आणि जर आपण सिंगल बीटला सेट किंवा रिसेट करत असू तर तो कोणता ऍड्रेस झाला?
बीट.
व्हेरी गुड. क्लिअर एव्हरीवन? कुणी असं आहे का की नाही कळालं मॅडम? रिपीट करा. कारण की एक्झामला स्पेसिफिकली मेन्शन करतात ते तुम्हाला की एक्सप्लेन एनी 2, एक्सप्लेन एनी 3 बीट ऍड्रेसेबल एरिया, सॉरी बीट ऍड्रेसेबल इन्स्ट्रक्शन्स. सो त्या केसमध्ये कन्फ्युज व्हायचं नाही की बीट ऍड्रेसेबल कुठल्या होत्या, बाईट ऍड्रेसेबल कुठल्या होत्या. क्लिअर झालं? नाउ सी. So see, set C means it will make your carry bit as a 1. Okay, next set B means it will make that particular bit which you have mentioned in the instruction set bit means it will particularly whatever the bit you have mentioned, it may be the port bit, any SFR bits. Okay, P1.0, it should be for example P3.1, it should be like PSW.0, that is 0th bit of the PSW. So it's SFR bits which you want to make to set. So see here, set C means your carry bit is going to set. Set bit means whatever the bit you have mentioned in the instruction, it is going to set. Next, CPL. In yesterday's lecture, what we have seen about the NOT gate. What is the NOT gate? NOT gate is nothing but the inversion or the complement. Now what NOT gate has to do? Whenever we want to give the 0th input, okay, it will give output as a 1. That is the, for example, you are giving 0 as an input, you will get output as a 1. If you are giving 1 as an input, it will make output as a 0. So CPL, this instruction is used to complement this value. Now see, CPL C, what this instruction has to do, it will complement the value of carry bit. If previously carry is 0, then it will make, after the execution of this instruction, it will make that carry as a 1. If the carry is 1 previously, then after the execution of CPL C instruction, your carry is become as a 0. So it will complement the carry value. Is it okay? Is it okay? Understood? Hello?
Yes, ma'am.
Okay. So next, CPL bit. So bit means what? Any value you are going to specify. Any bit you are going to specify. For example, if you have written PSW.0, what it means? 0th bit of PSW. So you have to complement that bit. Means what? If that bit is previously 1, then after execution it will become 0. If that bit is previously 0, then after execution this bit becomes 1. So you can complement the value. See here, what is the difference between set, reset and complement? See here. In the clear, what happens? It will compulsory make the bit equal to 0. In the set, it will compulsory make the bit equal to 1. It will not going to check the previous condition, whether it is 0 or whether it is 1. Clear makes the bit without checking the previous condition, it will directly make the bit 0. Here in the case set also the same thing happens. What? Without checking the previous bit, it will make, once compiler get the instruction set C, it will not check the condition of C. It will directly make the set bit equal, C carry bit is equal to 1. But that is not the case with complement. What happens in the complement? If there is an instruction complement C, what it means? It will first check what is the value of C. If it is 0, then only it will becomes 1. If it is 1, then only it will becomes 0. That is not the case with clear and set. Without checking the status of the carry, it will directly make the carry bit 0 if it is a clear, or directly make the carry bit as a 1 if it is a set instruction. Similarly, CPL bit, whatever the value you have specified here, without, in this complement case, it will first check the value. If it is 0, it will make 1. If it is 1, it will make it 0. That's why you will get the bar here. Bar means complement or inverse or simply not get. Okay. Now, see here next, ANL. In the last lecture, we have seen about the ANL. What is mean by ANL? What is mean by the ANL? Now you tell me by seeing this one, what is mean by ANL? ANL is which operation? ANL means which operation? And operation. Okay. So see here. But for this ANL, A comma data, you have to specify 8-bit value. Why? Because accumulator size is 8-bit. The same operation you can operate on the bit value, but you have to write another syntax like ANL C comma bit. Okay. What it means? You have to perform AND operation between carry value and bit value. Now see here, I will show the example so that you will get the clear idea. Now, how it can be executed? Now see, ANL, if I have written like that, ANL C comma 0. Okay, what it means? You have to perform the AND operation between 0 and the carry value. If carry value is 0, then AND operation is performed between 0 and 0 and you will get answer as a 0. Okay, now see, if the carry value is 1, then AND operation is performed between carry value and the 0 bit. Okay, and you will get the answer, whatever is the answer. What is the answer? 0. Why? Because AND is nothing but your multiplication. So whenever there is a single 0, you will get answer as a 0. So whatever the carry bit value. So see here, whatever the operation we have performed here, it is on a single bit. ओके, एकच बीट दिलं ना आपण 0 किंवा 1 आणि कॅरी मध्ये पण किती बीट आहेत? एकच बीट आहे. म्हणून हे जे एनएल ऑपरेशन आहे हे कसं आहे? बीट ऍड्रेसेबल. बट याच्या पुढे तुम्हाला अक्युमुलेटर मेन्शन करायचे का? नाही. डेटा मेन्शन करायचे का? नाही. हियर यू हॅव टू मेन्शन द बीट. विच बीट? if you want to perform the NL operation with carry, then you have to write here carry C, okay, and bit value, whether you want to perform it with 0 or whether you want to perform it with 1. Is it okay? See here, ANL C comma bit, here is a ANL C comma bit bar hai. Okay, bar means you have to take the opposite value. For example, see here, if I have written what? That ANL C comma 0 bar. This line is nothing but your bar, means it is treated as a 1. So AND operation is, if C value is for example 1, then AND operation is performed between this carry value and 1th bit. Okay, so 1 AND with 1, that is nothing but 1. If I have written ANL C comma hash to bit bar, and if I have given bit as a 1, okay, so it will take 1 bar means 0. Okay, so AND operation is performed between this 0 and carry value. So if your carry value is 1, then 1 ANDed with 0 is nothing but your 0. Why? Single 0 is nothing but 0 answer, as it is a multiplication. So for this bit, you can write any bit of the SFR. Like for example, if I have written here PSW 3.2, what it means? AND operation is performed between carry value and the PSW value. Okay, fourth bit of PSW value. Okay, if I have written like this, one instruction, now you going to tell me. Okay, so see here, ANL, it's ANL C comma. Instead of bit, you have to specify that bit. For example, P 0.1. Now tell me how it is going to be executed. If it is a first instruction. Now tell me how it is going to be executed. See here, it will execute the AND operation. Why? ANL is there. Okay, between what? Between carry value and second bit of the port 0. Okay, now see here. If port 0 second bit is 1. Okay, so it will take the value it as a 0. Why? There is a 1 bar. It will take the 0 value and it will again AND it the operation with carry value and it will give the result. Is it okay? Or shall I repeat once again? Hello. Is it okay or shall I repeat? Write on screen whatever is your feedback. Have you got the concept or shall I repeat once again? Hello, fast. Hello, are you there? Hello. Have you got or
Ma'am,
not?
repeat correct.
Okay. मग हे सांगा